Hello and welcome to C++ Weekly. I'm your host Jason Turner. I'm available for code reviews, contracting, and on-site training. In this episode, I'm going to build on the last episode where I discussed explicit constructors by talking about nodiscard constructors. So I'm going to put this in C++20 mode. Excuse me, C++2a mode, because 20 doesn't exist. And if I've got an object, let's just make our handy struct s here. And I've got main, and I construct an object of type s. I might get a warning, expression result unused. So let's make one that takes a value. And now we are creating a struct of type s, passing an integer to it. Clang gives us no warning at all. Now, if I were to make this constructor nodiscard, and this is C++11 attribute syntax, warning nodiscard cannot be applied to functions without return value. Now, that's true before C++20, and that's with Clang 9.0. So I'm going to go to Clang trunk, which is a pre-release 10 of Clang, and I'm getting ignoring temporary created by a constructor declared with nodiscard attribute. So if I don't have the nodiscard here, then I don't get a warning. If I do have the nodiscard, then I get this warning. This is distinctly different from a type that is declared nodiscard. So if I make the entire type nodiscard, let's go ahead and demonstrate what this looks like. I'm just going to create a factory function that returns one of these. And if I call it, I'm going to get a warning because I am ignoring the return value of a function declared with a nodiscard attribute. All right. If I take away the nodiscard attribute from the type, then I no longer get a warning here. So this is explicitly about making the constructor value itself nodiscard. So this code should not generate a warning anywhere because I am creating an object of this type. I am not throwing it away. I am in fact returning it to the function, and it's up to the call site to decide what to do with it. And again, if I make the actual type itself nodiscard, then I'm going to get this warning again. So you might wonder, why make our constructors nodiscard? And the idea is for constructors that do something. They acquire some sort of resource or something like that. So if we want to take these examples away and just put in some pseudocode here, and if I did something like try to get a unique lock on some sort of a mutex, this is going to return an object. This is a constructor call, that is. And I have just acquired a mutex and then thrown that result away. This is a perfect application for where we would want to see a nodiscard constructor. And similarly for unique pointer, if I did something like this, this thing is now managing a resource, but I just threw away the result of executing this constructor. So these are cases where the nodiscard for constructors was intended to be used, and that's in cases where you have acquired or managed some sort of a resource and then immediately throw it away. And it doesn't make any sense at all to make the entire type nodiscard because these are not error code types of any sort. They are just things that manage resources. If you have any ideas where in your own code that you might want to apply nodiscard to your constructors, feel free to share those in the comments here on YouTube, and thanks for watching this episode of C++ Weekly.